Welcome to the Unit 1, Section 1 video on solving equations. An equation is a mathematical statement making two expressions equal to each other. A solution of an equation is a value of the variable that makes the equation true. To solve an equation means to isolate the variable, which means get it by itself on one side of an equation. Isolating a variable by using inverse operations undo the operations on the variable. So, for example, addition and subtraction are inverse operations. You can use subtraction to undo addition. You can use addition to undo subtraction. Think of an equation as a scale and balance. A scale balances when each side holds equal weight. If you add weight to only one side, the scale is no longer in balance. However, if you add the same weight to each side, as shown here, the scale will balance. If the same number is added to each side of an equation, then the result is an equivalent equation. Equivalent equations are equations that have the same solution. So let's do a couple of examples and solve these two equations. Let's start with equation A. X minus 10 equals 4. We take that equation, and to undo the subtraction of 10, we're going to add 10 to each side. And when we add 10 to each side, the 10s on the left-hand side cancel out, leaving just x. And on the right-hand side, we do 4 plus 10, which gives us 14. For B, we have subtraction of 1/5 on the right-hand side next to the variable. So we are going to add 1/5 to each side to undo the subtraction. And when we do that, we end up with 3/5 on the left and m by itself on the right, since minus 1/5 and plus 1/5 cancel each other. In example 2, we're going to solve these two equations. So we've got x plus 7 equals 9. We have plus 7 behind the x, so to undo the plus 7, we are going to subtract 7 from each side, and that's going to give us x by itself on the left. 9 minus 7 on the right gives us 2. And we can do this with decimals as well. Same sort of approach here. We're adding 0.4 to the r, so we're going to subtract 0.4 from each side. Because remember, whatever you do to one side of the equation, you must do to the other to keep them equal. And then that gives us 0.3 on the left and r on the right, so r equals 0.3. And all of these equations that we just solved, all four of these, our solution means that if we take that solution and plug it back in for the variable, then we should get a statement that equals each other. Remember that subtracting is the same as adding the opposite. When solving equations, you will sometimes find it easier to add an opposite to both sides instead of subtracting. For example, this method may be useful when the equation contains negative numbers. So, in example A here, we've got negative 8 plus b equals 2. Well, we can add 8 to each side, and that's going to give us b equals 10. 2 plus 8 equals 10 on the right-hand side. For b, we've got negative 2.3 plus m equals 7. So, to undo a minus 2.3, we're going to add 2.3 to each side. It cancels on the left, leaving us with just m, and 7 plus 2.3 gives us 9.3 on the right-hand side. Now, just like we could undo addition and subtraction by using the inverse operations that they are, we can do a similar thing with multiplication and division. Solving an equation that contains multiplication or division is similar. We use inverse operations. So to undo division, we use multiplication. To undo multiplication, we use division. Remember that an equation is like a balanced scale. To keep the balance, whatever you do on one side of the equation, you must also do to the other side. So in example 4 here, we're going to solve each equation. So in A, we have k divided by negative 5. To get rid of that negative 5 on the bottom, because we're dividing, we need to multiply each side by negative 5. And when we do, we get negative 5 times negative 4 on the left, which gives us 20. And then the negative 5 on the bottom and negative 5 on the top on the right-hand side cancel each other, leaving us with just k. So in this equation, k equals 20. For b, we have m divided by 3. So to get rid of the 3 on the bottom, because we're dividing, we're going to multiply by 3. Multiplying each side by 3 gives us m on the left-hand side. 3 times 1.5 gives us 4.5 on the right-hand side. Now for this set of examples, we have multiplication. In A, we have 7 times x. So to undo that multiplication, we must divide each side by 7. We end up with x on the left. 56 divided by 7 gives us 8 on the right. Same deal with B. We've got negative 2 times w on the right-hand side, so we're going to divide each side by negative 2. 13 divided by negative 2 is going to give us negative 6.5. And of course, the negative 2's cancel on the right, giving us w. So in this case, w equals negative 6.5. Remember that dividing is the same as multiplying by the reciprocal. Remember, the reciprocal is when you take a fraction and you flip it. When solving equations, you will sometimes find it easier to multiply by a reciprocal instead of dividing. This is often true when an equation contains fractions. So, for A here, we have 5/9 times v equals 35. So to divide each side by 5/9 is the same as multiplying by 9 over 5. We multiply by the reciprocal. On the left-hand side, the 9's cancel because you got one on the top and one on the bottom. The 5's cancel because you have one on the top and one on the bottom, leaving just v on the left-hand side. On the right-hand side, you can do 35 divided by 5, which is 7, and then 7 times 9 gives you 63. For B, we're going to multiply each side by 3/4. And when we do, we're going to get 15 over 8, because remember, when you multiply fractions, you multiply straight across. 3 times 5 is 15. 4 times 2 is 8 on the bottom. And of course, your 4/3 and 3/4 cancel each other on the right-hand side. Now let's talk about solving two-step equations. So all the equations we've dealt with up to this point are considered one-step equations. It takes only one step to come to the solution. Solving some types of equations require more than one step. To solve an equation with more than one operation, undo the operations in reverse order. In other words, work backwards. So to solve each equation here, we're going to have to utilize two steps. So let's start with A. What we want to do is start from the outside and work our way in toward the variable. So on the right-hand side, the first thing we can do is we can subtract 6 from each side. When we do, we end up with 10 minus 6, which is 4 on the left, and then 6 minus 6 on the right becomes 0, and that just leaves us with negative 2x. Then we're going to divide each side by negative 2 to get to our x value. 4 divided by negative 2 gives us negative 2, and that is our value for x. For b, we're going to, again, start from the outside and work our way in. So we're going to start with adding 1/5 to each side. And when we do, we're left with q over 15 on the left. 3/5 plus 1/5 gives us 4/5. And then we're going to multiply each side by 15. That's going to give us q on the left, and we can work it out as 15 divided by 5 on the right, which gives us 3, and 3 times 4 gives us 12. Or you can do 4 times 15, which gives us 60, divide that by 5, and that gives us 12 as well. To solve multi-step equations, we just take what we've already done and we continue to work it up a notch. Equations that are more complicated may have to be simplified before they can be solved, meaning you may have to use the distributive property or combine like terms before you begin using inverse operations. So the distributive property states that for any numbers a, b, and c, a times the quantity b plus c is equal to ab plus ac. So in other words, you take your a and multiply it by the b. You also take that a and you multiply it by the c. And you can also reverse it. You can have a be on the other side of the parentheses. It still works either way. Also works for subtraction as well. Notice that the distributive property works both ways. Doesn't matter if a is placed on the left or the right of the expression in parentheses. You can still distribute it either way because what you're doing is you're multiplying the thing that's in the parentheses by whatever's outside of the parentheses. I think this will be clearer when we do a few examples. So let's start with a here. The distributive property will not be required for a, so let's go ahead and combine the like terms. 6x minus 8x is going to give us negative 2x. We still have our plus 3, and now we can subtract 3 from each side. That's going to give us negative 2x equals 10, and then we divide each side by negative 2. And that leaves us with x on the left and negative 5 on the right. Now for b, we are going to use the distributive property. It's not quite clear yet, but that negative sign outside of the parentheses is the same as saying negative 1 times what's in that parentheses. Okay? So remember, minus is the same thing as plus a negative. So we've got 6 plus negative 1 times x plus 2, and we're going to distribute that negative 1 to the x, and we're going to distribute the negative 1 to the 2, like so. And then that leaves us with 6 minus x minus 2. We combine our 6 and our negative 2 to give us 4, and then we subtract 4 from each side. 9 minus 4 gives us 5, which is equal to negative x. And if 5 equals negative x, then therefore negative 5 must equal x. So you either multiply each side by negative 1, or you divide each side by negative 1, and that takes care of the negative in front of the x, giving us our solution. So now let's talk about solving equations with variables on both sides. Many equations contain variables on each side. To solve an equation like this, just like we've done with numbers or constants, we're going to use inverse operations to collect the variable terms on one side of the equation. So now that we've discussed this, let's just talk about the steps in general for solving equations. You're going to start by removing all parentheses by using the distributive property. Then you'll simplify both sides of the equation by combining like terms. Once all your like terms are combined, get all the variables to one side of the equation using addition or subtraction. Get all the constants or numbers to the other side of the equation using addition or subtraction. And then remove the coefficient of the variable using multiplication or division. Now that's a lot of steps, so it may be helpful to use a mnemonic device to remember these steps. And the mnemonic device that you can use is called "Don't Call Me After Midnight." The first letter of each word in that phrase is a step. You're going to start by distributing, by multiplying the term outside the parentheses by the inside. Then you're going to combine like terms with the signs of the term. You're going to move the variable with the inverse operations. You're going to add or subtract using properties of equality. And then you're going to multiply or divide using properties of equality to get the variable by itself. So let's talk about a couple of examples. So in A, there's nothing to distribute. There's no like terms to combine, so we move straight to moving the variable. We're going to move the 4k to the other side by subtracting it from each side. And when we do that, we get 3k on the left and 15 on the right. There's nothing left to add or subtract, so we're going to multiply or divide to get the k by itself. And in this case, we're going to divide each side by 3, and that leaves us with k equals 5. For B, first we are going to move the variable because there's nothing to distribute and there's no like terms to combine on either side. So we're going to move the variable by subtracting 3x from each side. 5x minus 3x gives us 2x on the left. Of course, we still have the minus 2, and we're left with the 4 on the right. Now we're going to add or subtract. In this case, we're adding 2 to each side. That leaves 2x by itself, and then 6 on the right-hand side. And now finally, to get the x by itself, we're going to divide each side by 2, giving us x equals 3. To solve more complicated equations, you may need to first simplify by using the distributive property or combining like terms. So now we're going to pull in those first two steps that you did not see in those previous two examples. So in A, first thing we're going to do is distribute the 2. That gives us 2 times y plus 2 times 6 equals 3y, which is 2y plus 12. Now, there are no like terms to combine, so now we are going to move the variable by subtracting 2y from each side, and that leaves us with 12 equals y. So now we have our solution. For B, we have a negative 2 to distribute on the right-hand side. So we have negative 2 times 1, and we also have negative 2 times negative b. Once we finish that out, we have negative 2 plus 2b on the right-hand side. Now we're going to combine like terms. On the left-hand side, we're going to combine negative 5b and positive 2b. On the right-hand side, we're going to combine negative 2 and negative 2. So now we have 3 minus 3b equals negative 4 plus 2b. Now we're going to move the variable by either subtracting 2b from each side, or so that we don't have to deal with something that's negative, we can add 3b to each side. So that's the option we're going to take here. Adding 3b to each side leaves us with 3 on the left and negative 4 plus 5b on the right. And then we're going to add 4 to each side. That's going to give us 7 on the left and 5b on the right. And then finally, divide each side by 5, and we get that b is 7/5. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.